Today, in this video lecture, we will see shear force diagram and bending moment diagram of this O-ring beam. We will understand first this beam, then we will judge bending moment diagram and shear force diagram. Then we will calculate values of that bending moment diagram and shear force diagram by using manual calculation, and after that we will solve this by using StatPro software also. So first understand this beam. This is O-ring beam. At point A there is reaction RA, at point B reaction RB, and B to C portion is O-ring portion, and total span of this beam is 9 meter. Loading is 2 kN per meter loading throughout this beam, and 5 kN loading is at point C, concentrated point load 5 kN, and at point A there is a vertical reaction RA, and at point B there is vertical reaction RB. So first judge shear force diagram of this beam. From left hand side to right hand side, see this beam. See first reaction RA. It is vertical. So shear goes vertical due to this reaction RA. Then after reaction RA, see this loading. A to B portion loading is uniformly distributed loading. Due to uniformly distributed loading, shear force line is inclined line. So this is like this. Then see support B is vertical reaction. So this is like this, upward due to vertical reaction. Again see B to C portion, there is UDL. UDL, that means inclined line. And again see this 5 kN downward concentrated point load, so downward shear. So here positive, negative, positive. So on which support, at support A or at support B, shear is positive, shear is maximum. At which support, between RA and RB, shear is maximum. So for that, understand. First see this support. This support have this 5 kN load, and this load is near to this RB support, and this load is also near to this RB support, and this RA support have only this load. So as per my judgment, RB support is maximum shear. Why RB support is maximum shear? Because more load is near to that RB support. So here it is maximum reaction comes. Maximum reaction or maximum shear. So this is judgmental shear force diagram. This is judgmental. We will see exact values and exact shape of this, exact and correct shear force diagram of this later. Now see this point. Here shear force is 0, that means bending moment is maximum. Before that, see, this is O-ring beam, this 2 kN per meter. So deflection like this. See, this is sagging, and this is hogging like shape. Sagging is like this, and hogging is like this. So At portion A there is zero movement because of only RA vertical reaction, there is no movement. So AB portion there is UDL. UDL, that means bending moment is parabolic line. See here it is maximum where shear is 0. Now it drops down, and at B it is negative, and at C it is like this negative, because here see hogging hogging deflection occurs. That's why I judge this like this. Here maximum bending moment occurs. Now calculate exact RA and RB reactions. Vertical reaction is positive and downward reaction is negative. So RA and RB is upward vertical. So positive RA plus positive RB, and this 2 kN per meter is acting like this. Convert this 2 kN per meter UDL load into concentrated point load. So it is like this downward 2 into 6. 6 is length of that AB portion where it is acting. And again see this BC portion have also this 2 kN per meter load acts. So this is also 2 into this BC portion length is 3 meter. So I convert this UDL into point loads. So, and this is downward, that means minus 2 into 6, minus 2 into 3, and this is 5 also. See this 5. So minus 2 into 6, minus 2 into 3, minus 5. So this RA plus RB is equal to 23 kilonewton. Now see, we calculate RA plus RB, but we need separate reaction RA and separate reaction RB. So for that, see this beam. For that, take moment at this A point. Summation of moment at A is equal to 0. While calculation of moment, we consider our assumption is clockwise moment positive and anti-clockwise moment negative. And we will calculate moment here at this point A. So this 2 into 6 is clockwise and it is acting at 3 meter, because this 2 into 6 is at mid of this AB span. So mid of this AB span, that means from A it is 3 meter. So due to clockwise, positive sign comes. Positive 2 into 6 and lever arm is 3. Lever arm, that means distance from point load to that point A. Again 2 into 3 into between B distance is 1.5 meter, because this concentrated point load is acting at mid of this BC. So 6 plus 1.5, 7.5. So clockwise, that means positive 2 into 3 into 7.5 meter. Again at point C, load is clockwise to that point A, so positive 5 into total distance is 9. So these are all point loads. Now consider RB reaction also, minus RB into 6. RB is anti-clockwise to that point A, so minus RB into 6 equal to 0. Cross check it again. 2 into 6 into 3, correct. 2 into 3 into 7.5, correct. 5 into 9 and RB into 6, yes, correct. So calculate RB in Calci. Positive 2 into 6 into 3 plus 2 into 3 into 7.5 plus 5 into 9 minus RB into 6 equal to 0. So it is 21 kilonewton. Now calculate this RB value in equation 1. This is equation 1. So RA is equal to 23 minus 21 is 2 kilonewton. So this RA is 2 kilonewton and RB is 23 kilonewton. And this RA is nothing but the shear reaction is shear 21 kilonewton. So RA is 2 kilonewton, not 21. So now next step is to calculate shear force diagram. So shear force at A is reaction at A, and reaction at A is 2 kilonewton. Next is this point B, left side. Shear force at point B, just left to that point B. So for that, the support reaction RA minus 2 into 6. This is minus 10 kilonewton. Now next is shear force at B, just right to that. This minus 10 plus reaction RB. RB reaction is 23 kilonewton. So it is 13 kilonewton. Minus 10 plus 23. See this. RB is 21, not 23. See how mistakes happens. Learn from mistakes. 21. So it is minus positive 11 kilonewton. So next is shear force at C, just left to that C. Positive 11 and this inclined C, this 3 into 2 concentrated point load downward, so minus 2 into 3. That means minus 6. That means 5 kilonewton. here minus 10 kilonewton, here 11 kilonewton, and here 5 kilonewton. That means our judgmental shape is correct and judgmental maximum shear is also correct. See, see this. See this. I write here maximum, and our maximum shear comes at this. See this line, 11 kilonewton. Now calculate bending moment also. BMD, bending moment at point A equal to 0 because it is only vertical reaction and unit is kilonewton meter. Bending moment at this B, bending moment at B equal to bending moment at B, I calculate it from this side, right to left. So this 5 kilonewton is clockwise to that B, so positive 5 into 3. And this UDL is also clockwise to that point B, so positive 2 into 3 into 1.5. Distance is 1.5. So this is 5 into 3, positive 2 into 3 into 1.5. It is 24 kilonewton meter. And remember, very important point, when we calculate bending moment from right to left, change this sign. This is positive, change to negative. And see, our judgmental shape is also correct. Here it is minus 24, here it is 0. And here also 0. Now calculate maximum bending moment. Where moment is maximum, see here, shear force is 0. So this is 2 kilonewton. This is 2 kilonewton per meter. This is X. So this is, let's assume this as Vx and this as Mx. So upward is positive 2, downward is minus Vx and minus 2x equal to 0. Vx is 0, that means 2 is equal to 2x. So x is equal to 1 meter. Shear is 0 at 1 meter from point A. That means bending moment is maximum at 1 meter from point A. Now calculate bending moment. This mx is anti-clockwise, that's why minus mx. We will calculate bending moment at this portion. So minus mx, positive 2 into x, and this UDL is 2x into x by 2. That's why mx is equal to 2x plus 2x square by 2, and x is equal to 1, so 2 plus 2 by 2 is 1. See this, mx is anti-clockwise. So here this is minus. Remember where mistakes happens. And this is minus. So mx is equal to 1 kilonewton meter. This is maximum moment. Maximum. Why maximum? So my bending moment diagram judgment is wrong. See here, this 1 kilonewton meter is not maximum. This 24 is maximum. For maximum moment judgment, consider CG of this load and take CG of load and where for which point this CG is near, at that point moment is maximum. So this is thumb rule. See, this is point of contra picture where bending moment changes sign. Unit of bending moment is kilonewton meter and unit of SFD is kilonewton. So let's calculate this y distance where point of contra picture occurs. So for that, but use bending moment is equal to 0 equation. So where point of contra picture occurs, there bending moment is 0. Consider point of contra picture occurs here, this space. So take moment at this space. This mx is minus mx because it is anti-clockwise plus 2x minus 2x into x by 2 and mx is 0. That means 2x is equal to 2x square by 2. This x get cancelled. This 2 is equal to x. So x is equal to 2 meter from point A. So this is 2 meter. This SFD BMD is not as per scale. Correct it as per scale and dimensions. Now we will calculate this SFD BMD in StatPro software also. New metric, create. Our beam total length is 9 meter. That means 6 plus 3. It is 9. Add beam. This is 6 and this is 3. Total is 9. View properties for errorless analysis. Rectangle 0.23 meter by 0.45 meter. Add, close, assign to view, assign, yes. Material, concrete, assign to view, assign, yes. We will calculate bending moment for only live load calculation, but for errorless analysis we need to provide this data. So this is only Fy is reaction here, all others are releases. Add, select, use cursor to assign, shift and N, shift K. Why it is not seen? For node scene purpose, shift K, yes. When we put shift K, then node comes and node go. Shift K, see node go away. Shift K, node comes. Now loading, live load case, and loading type live load title, add, close, click on live load, add. Our live load is UDL and point load. So UDL is member load, uniform force, minus because it is downward, and value is 2 kN per meter downward. So select, assign to view, assign, yes. Right click, labels, scale, see this UDL is correctly acting. Now apply concentrated point load at this point C. It's minus 5 kN at a distance 3 meter. Add, close. Why distance 3 meter? Because this is 3 meter length beam and B to C. Member concentrated force downward, that's why minus, and 5, and D1 is 3. So select, first click on load, then click on beam, then assign to selected beam, assign, yes. So analysis, define command, all, add, close, and run analysis. So let's see bending moment and shear force for that live load. See deflection. See maximum ends and midpoint here. What is floats? So see, this is 2 kilonewton, this is 2 kilonewton, this is minus 10, this is 11, this is here it is 5 kilonewton. Let's see in electrical modeling. Here bending at a distance of 3 meter it is 0, at a distance of 2.9 it is see shear Y. Think. Now see movement. See this is 1 kiloton per meter. This is minus 24. See this is 24. Instead it shows hogging bending moment is positive and our calculated hogging bending moment is negative. So this is difference. Let's see this beam bending at 1 meter distance. See it is minus 1 kilonewton per kilonewton meter. Our is 1 kilonewton meter sagging bending moment. Instead minus that means it is sagging. So it is correct. Our analytical and numerical SFD BMD both are match each other. So at point 1 at point 2 meter bending is 0 C.